Hello, everyone, and welcome to another online viewing session hosted by the Kalamazoo Astronomical Society. My name is Richard Bell. I am the president of the Kalamazoo Astronomical Society, and I am your host for this evening. And I want to welcome you back to our second online viewing session of the year, and also our last event completely of the year. So this is it for us tonight until next year, which, as I'll mention later, will be our special 90th anniversary year. So we got a huge year of celebrating to do. It's going to be a lot of fun. So originally on this night, months ago, I scheduled a Geminid meteor shower watch. But then when I started putting together the schedule for online viewing sessions, I realized, gee, this is the best night to do an online viewing session. And to be blunt, we get more people here than we would outside observing for the Geminid meteor shower. So I figured, let's just do an online viewing session. And if it is clear, we could run outside. At least those of us, that have clear skies could run out and view the Geminids, because it doesn't really get good until a little later in the evening. But it's extremely cold out there. It's snowing. It's completely overcast, obviously. So there's no chance for any Geminids for us tonight, at least here in West Michigan. But we'll check our all-sky camera from time to time and see what kind of things we can see on the camera. Maybe we'll catch a few Geminids in the act here and there. So I think we're just about 100% ready to go. So let's go ahead and jump right into it. I'm going to go back and share my screen here again. And make sure I get on the right screen there. So again, welcome to the online viewing session for December 13th, 2025. This picture here was taken during some sunrise, probably a few years ago, because I've used this image a lot for our opening title slide for online viewing sessions. And this is by Mike Patton, who owns the observatory that is pictured here. And this is the home of the KAS Remote Telescope near Portal, Arizona. And I don't know what it is with some of these ASV folks. They seem to get up at the crack of dawn. If it were me, I'd be up all night, and I wouldn't get up till noon or 1 because I'd be imaging all night. But apparently another member who's also an ASV resident was out very early this morning and took this picture. So this is actually today, a little after sunrise at Arizona Sky Village. So this is by KAS member Jim Kurtz, who lives very close by to Mike Patton. And that's Jim's observatory center, and his house on the right. You can see he has some Christmas bling or Christmas tinsel up there. And he captured this nifty sundog this morning. So this is facing toward the southeast. He could probably tell us roughly what time in the chat. My guess is probably around 8:30 or so in the morning. And so he did capture this really cool sundog. And these are basically generated as sunlight is reflected and refracted in flat six-sided water ice crystals. So that's what the sky looked like around Arizona Sky Village this morning. And there were some clouds very recently here as well. So we're going to go back and check that on the all-sky camera here soon. But here's another view of Peishi Observatory. If you've ever attended an online viewing session, you've seen me use this image before. And so this is Peishi Observatory, which is Apache for Nighthawk. And it's a 20 by 20 roll-off roof observatory, owned again by KAS member Mike Patton. And there are 3 telescopes in there, one of which is the remote telescope right there. So you can see it kind of popping up there. And we have our weather station, which will check the weather later. And then we have this little gadget here, which is our all-sky camera. So this is our second all-sky camera out there. We just upgraded last season. We got to show this off for the first time. So our new camera consists of a ZWO ASI 183 color camera, coupled with a Fujinon 2.7 millimeter f1.8 fisheye lens. And again, thanks to Jim Kurtz, who I mentioned earlier, for putting this together for us. But we actually got the idea from another part-time resident, Dave Churchill, he has an observatory nearby with the same setup for his camera because we liked his camera so much. We got a similar setup because his is much better than the old S-Big camera with a little tiny CCD chip that we used to use. And we control this with a program called All Sky. It's all SK and EI, EYE, all Sky. It's kind of weird to say. So let's go ahead and check the All Sky camera here. So let's see, how do I do that? I have to get back to Zoom or try to. Where'd Zoom go? It won't pop up on my screen. Okay, let me see if I can minimize that, make that go away. My goodness, where did it go? I've lost Zoom. Where'd it go? Oh, it's hiding behind somewhere. Oh, it's on my other screen. Okay, well, that's going to be irritating. Okay, so let me select the right screen there. And there we go. So now I can switch over to the, I think I got it. There we go. Can you guys see that? Of course, you can't hear me. I'm trying a new setup here, so it's getting a little confusing. Let me just stop sharing altogether there. There we go. And hopefully you guys can see that. And let me go here. Now that should work. For some reason, the YouTube stream isn't updating. So I hope they're okay there on YouTube. So maybe I better give you guys the ability to unmute yourself. So if there is something wrong, you can tell me. Because I gotta let some people in too. Okay, so you folks can unmute yourself now. So if you can't see the All Sky camera, just go ahead and yell at me. But here's the All Sky camera. The current view, you can see it's roughly 8:40 Eastern Standard Time, and Arizona is roughly 2 hours behind us. So this is about roughly 6 minutes old now, and it'll probably update in the course of me talking about it here. And you can see this is our bird perch in the foreground, which keeps birds off the dome and from doing their business on the dome. So that bird perch comes in really handy. And when I first logged on here to get set up, the western sky here was kind of full of clouds. But now it looks like we're going to get a break here with clouds because I don't know, for those of you that stayed after during the last online viewing session, is we had great weather for the 2 hours that we were here. But not long after we logged off, it started clouding up really bad. And so that might happen again tonight, but hopefully it won't happen as we're doing the session here. So you can see the current night sky above Arizona Sky Village. It is nice and clear. So you can check out this all sky camera yourself all the time by going to our website, kasonline.org, and go to the remote telescope menu and pull up the Piishi all sky camera there. So at home, you can watch this. And if you spot a Geminid while I'm talking about something else, you can kind of give us a holler. We can switch back to the all sky camera real quick and see if we actually pick up any Geminids. So let me give you a quick tour of the sky above Arizona Sky Village. We're almost at winter now, but we still have this big asterism right here. This is the summer triangle made up of Vega, Deneb, and Altair. And so it's dubbed the summer triangle because it rises in the east at the beginning of summer, which we're well past. So here it is way over in the western sky, beginning to roughly set here, but it still has a couple hours to go. And Vega is part of the constellation Lyra, the lyre like a harp. And there's a little isosceles triangle here with a parallelogram. And so it's a very small constellation. Pretty much everyone knows that we have M57 right between these two stars there. We've never done that at an online viewing session because it'd actually be kind of small on our large CCD chip there. So we've never actually done that one. We've done the Dumbbell Nebula like over here somewhere plenty of times, but we've never done the Ring Nebula. Then we go over from Vega to Deneb. This is part of another asterism called the Northern Cross that goes down to this star here, Albirio, with Satyr here, and then these two stars on either side. But this is also the tail of Cygnus the Swan. So Albirio is the head of the swan, with kind of a bent neck here. You can kind of see it a little bit. And then the wings just to extend out a little further. There's like 3 faint stars there for the wingtips, and then another star out here for the rest of the wing there. So Cygnus is kind of flying toward the western sky there, toward the mountains. Then finally we have Altair, which is the head of Aquila the eagle. And near Altair is another kind of tiny triangle that forms the body of the swan, or sorry, the eagle. And there's kind of a crooked wing here, and then kind of a straight wing there, and the tail feathers are just kind of down in the clouds and the glow here from sunset. So the eagle's kind of flying in the opposite direction from the swan. And you can see a bit of a glow here. It'll become more prominent as the sky grows darker, but here we have the Milky Way, the disk of our home galaxy, seen within. And as we kind of travel through the summer triangle, we'll come back to this area later, or very shortly, when we start looking at stuff with the telescope. We'll go through this region. Oh, I just got an update. And we come across Cassiopeia. And then over here is Perseus with the Pleiades cluster, the Hyades cluster, and Taurus. And you can start to see some really good winter constellations. We do have Taurus, of course, which is a very prominent winter constellation. And we have Aurea the Charioteer with the star Capella. Looks like a big house in the sky. And you can just begin to see Orion rise almost due east here. You can see the 3 stars in a row with Betelgeuse and Bellatrix and Rigel. You can't see Safe yet, but Rigel is in the course of, or Orion is in the course of rising right now. And pretty much dead center, right at the zenith, is the dominant asterism of Fall, which it's still technically Fall, at least astronomically speaking. We have the Great Square in Pegasus, which is actually made of 2 constellations. These 3 do belong to Pegasus, the winged horse. Here's his head. And then we have Alpheratz, which is the head of Andromeda, which is these 2 arcs of stars here, kind of the brighter arc on the bottom, then this fainter arc on the top. And later on, we'll be looking at a very popular target right about there, because we have to do it once a season. And tonight's the night that we're going to do it, because we didn't do it last month, so we're going to do it this month. And then you can see some constellations kind of low in the south here. We have Cetus the whale. Kind of looks like a vacuum cleaner. That's what I always thought. There's kind of this shape here and this straight line of stars, and like maybe like a little handle on the vacuum cleaner, but you know, it's supposed to be a whale. And then kind of over here, you can't see it too well because of the clouds, and the glow is Capricornus. But those are some of the constellations of Fall. Oh, and I will mention right here is Polaris, the North Star. So we have the 3 stars in Ursa Minor, or the Little Dipper, and the 4 stars in the Bull, or the body of the bear. So going straight down, and due north is right there. Of course, due west is over here. It's backwards, just like it is on a star chart. And then we have due east, where Orion is rising, of course, south below. So that's our tour of the sky above. So let me go back to the PowerPoint here, and we'll introduce our first target of the night, which we're going to use our Takahashi telescope first, as always. So this is our Takahashi FSQ 106 EDX3, which is a very nice 4-inch refractor with a Nightcrawler 2 focuser. So as always, we start with the Takahashi, which gives excellent wide field views. It really complements the bigger scope we'll use later. And this is our current camera, our SBIG STX 16803, which is a full frame, and it's even more full frame than your regular full frame cameras, because most full frame cameras are 36 by 24, but this is nearly 37 millimeters square, so it's a big square chip. But we're going to be upgrading our cameras probably next year. I might mention more of that later. I mentioned last month that we had another 20-inch CDK donated to the club, and we do have a buyer for that now. So we'll be using that money to help upgrade the remote telescope, make it even bigger and better than before. Well, maybe not bigger; it'll still be the same size telescope, but you get the idea. It'll have some newer cameras and all the latest gear. We try to keep it up to date if we can. Okay, so this is our very first target of the night. Colander 399, otherwise known as the coat hanger. And so before we begin talking about it, let's switch to another program here. We'll go back to the web browser. Here we go. And then I'm going to click on the tab there. And you can see this is ACP, which stands for the Astronomer's Control Panel. And this is what we use to control the remote telescope from very far away. And this is developed by a guy named Bob Denny, and he's about ready to retire. So ACP is going to be discontinued soon. He actually, we always tend to renew our ACP license in October, and this year he never even sent us an email. So that really indicates he's not accepting renewals because he's going to retire. So we'll be upgrading the software we use to control the remote telescope too. We're likely going to switch to one called Voyager, which is developed by an Italian astrophotographer. So we're really looking forward to trying that out. Although it'll probably be kind of fun to set up too. And I already have it entered in. I already have the object entered in. So I typed in Colander 399, hit get coordinates. This should be the proper coordinates. We're going to do a 5-minute exposure with our clear luminance filter. I've already focused, so we're not going to bother to focus. And so I'm going to go ahead and hit acquire image. And we can watch it work here. It'll begin to slew the telescope. And I wish I could show you the telescope live, but we still haven't got that going yet, unfortunately. I could try to hold up my iPad to the screen later so you can see it on there, because right now we can only view it on a tablet or a phone. I can't get it on the computer yet to share with you. So let me hop back to the PowerPoint here. And so this is our first target for the night. And this is one we've done before. In fact, all the targets we are doing tonight are ones we have done before, because things have just been so busy with me lately with work, and I'm trying to work on a grant to pay for our special programming next year, and with the newsletter and all the other stuff I do, just haven't had time to research new targets for tonight. So we're doing some of the fun targets tonight. So this is also known formally as Brocchi's cluster or Al-Sufi's cluster. And it was first described by the Persian astronomer Al-Sufi in his Book of Fixed Stars in the year 964 CE. And it was independently rediscovered by the Italian astronomer G.B. Hodirna in the 17th century. In the 1920s, Delmaro Francis Brocchi, an amateur astronomer and chart maker for the American Association of Variable Star Observers, the AAVSO, created a map of this object for use in calibrating photometers. And in 1931, the Swedish astronomer Per Colander listed it in his catalog of open clusters. It's located almost halfway between Alpha Vulpeculae and Alpha Sagitta, as a kind of a mottled haze with the unaided eye. So you can see this with the unaided eye as kind of a patch in the sky, although if you do have really good eyesight, you might be able to pick this thing out without the aid of binoculars or a wide field telescope, because it's pretty big, which is why we're using the Takahashi. But it's basically right in the summer triangle here. We got, again, Vega, Deneb, and Altair. And we see the more obscure constellations, Vulpecula, the Fox, and Sagitta, the Arrow. This is the region where you find the Dumbbell Nebula. And then kind of nearby is this really large target here called Colander 399. And again, it's located about halfway between Alpha Vulpeculae, which is here. Oh, oops. No, that's Delphinus, sorry. Right here. And then Alpha Sagitta right here. So roughly halfway between the two there. And it's a great binocular target. All right. So let's see. Gonna get dizzy switching back and forth here. Let's see how we're doing. So we've already started our image. We're gonna do again a 5-minute exposure, or that's 300 seconds to you and me. And you can see we have a guide star. We are guiding. And let me show you the behind the scenes view here. Should still be open. There we go. So using any desk here, I can access the computer in the observatory out west. And you can see our guide star there. And this is just a picture it took. We can actually get rid of that. That's the picture it took to look for the guide star, or at least to frame it anyway. Yeah, that's the framing picture. Sorry. And this is the program here in the middle. The big one is MaximDL. This is what we use to control the camera and the auto guider. And you can see it's running the camera, doing the 300-second exposure. And over here is a program called Focus Max, which I used to focus the telescope before we started tonight. But we can get rid of that. And here's ACP. You can see I am connected. There I am. That's me. And then we have M1 Oasis, the program we use to open and close the observatory roof. And here's our weather station. So you can see it is clear. It is calm. Thank goodness. That means the wind is under 5 miles per hour. That's how we define calm. If it gets over 5, then it's classified as windy. Then over 10 miles per hour, it's very windy. So now it's a very calm 2.7 miles per hour, only 30% humidity. Oh, that's just awful. It just makes me so upset. It's a lot more humid here now. And you can see the temperature is nearly 61 degrees. And we're with the wind chill in West Michigan, we are below 0 right now. It's like -4 last time I checked. And you can see it's pretty dark. Usually when it's around 150, that means it's pretty dark. It's about as dark as it's going to get out there. So that's the current weather. And that's what this is our camera ticking away there. So again, we can escape from the screen sharing there for a second. And I welcome questions or comments or reactions. And if anybody just wants to say hi, tell us where you're from, you can do so live here or in the chat. So hopefully we have a lively crowd. I mean, last month, man, what a bunch of deadbeats last month. I hope you guys are much more fun.
Hey, Richard, this is Eric.
Hi, Eric.
As you know, we're in nice, cold, cloudy Michigan. So there you go.
Yep. You're not outside imaging tonight, right?
No, not this time.
I would hope not.
My telescope screams to go outside, and I have to keep telling it, you're going to have to wait.
Yep, it's going to have to wait till at least May.
Yep.
Great.
Hey, Richard, how's it going?
It's great. Hi, Tim.
Just checking in, saying hello.
Oh, great. Wonderful. Just kind of looking through to see who we have in here. Yeah, let's see if I can. There we go. One of our members asked to be made co-host so he can let people in. So he now has the ability to do that. So that takes the burden off me. And I just heard a chime, which means our exposure is done. So go back and share the screen there. There we go. Oh, it looks a little hazy. Uh-oh, yeah, it is kind of hazy. Yeah, okay, we're looking through clouds tonight. At least that low. But it looks pretty cool. So what it does is it downloads the image. It creates a thumbnail first. And then it's going to like count stars. So 56,396 image stars found. And it'll do a plate solve. And then eventually it'll process kind of a larger version. And there we go. And it's done. So here we go. Our first image of the night. Colander 399, otherwise known as the coat hanger. So go ahead and unmute yourselves if you're not already. And here we go. Ooh, cool effect with the clouds there.
That's pretty
That's
neat.
actually kind of cool.
Very
That
nice.
is good. Yes.
That's
Now,
neat,
me
Richard. Really neat.
isn't it? I always like looking at this one. Now, me personally, I call this the mommy dearest cluster. If you know that joke, then you are officially
Well, now you have to tell it.
well, no wire coat hangers, obviously. Look it up on YouTube. I don't want to go into it.
Oh, okay.
It's
Okay.
not a,
Okay.
it's not a pleasant story.
Oh, well, you said a joke, but maybe not. I get it.
No, it's from a movie. No wire coat hangers. It's quite an awful scene.
Okay. We'll leave it at that.
This is whenever I have a wide field telescope, this is one I like to show in the summer. So now, of course, this has long been kind of called Brocchi's cluster or Al-Sufi's cluster, but in 1998, Brian Skiff discovered that this, to probably not too many people's surprise, was discovered to be an unrelated group and basically an asterism. So this is not a cluster. It is just a random alignment of stars that really seem to have nothing to do with one another. And so it is an asterism made up of about 10 stars ranging from 5th to 7th magnitude. And there's a straight line of 6 stars there, as you can see, with a hook of 4 stars on the south side. So the stars range from 354 to 2,237 light years distant. So that's a huge distance range. So that clearly tells us they have nothing to do with one another. There is a genuine open cluster located 17 arc minutes, 33 arc seconds east of 7 Vulpeculae, the easternmost star of the coat hanger. And it does have an elongated appearance through telescopes, and I believe you can see it right there. There it is. It might be resolved better when you check out the high resolution version when you download these later. And it has a magnitude of 8.8, an angular diameter of just 5 arc minutes, and it's about 5,800 light years away. So there is an actual open cluster in there, probably a few if you look hard enough. This could be an open cluster down there, but so I don't know. It is a little hazy. If anybody wants this image, that's cool, but if you would prefer I replace it with a cool one that we did from before, I could do that too, where you don't have all the glow and stuff like that. So let me know your preference. Glow or no glow. All right, so that's
The glow's pretty neat. I like the glow.
okay. All right. So we'll give you this one. It is kind of a neat effect.
So is the glow because of the clouds? Are there
Yes.
clouds that are making it glowy? Okay.
Yep. Yeah, you can see it. You can't quite see it on the off-sky camera here, but you can definitely see some clouds here. So there's probably some fainter, wispier stuff right around here because it's like right here. The thing's not very high, but I haven't done this one in a few years, so I figured we'll do this one tonight. But yeah, it's like right around here. So we're looking pretty
okay.
low, and it's just above where you can really see the clouds. So there's probably some haze in there that we can't quite make out on the all-sky camera. But there it is. So again, this is live. This is not a archived image. We just took that. Okay, now our next target needs no introduction, but of course we'll do it anyway. We'll type in M31 there. Go ahead and hit get coordinates. We'll go ahead and do a 5-minute exposure with the luminance filter, and off we go. So we'll let it do its thing here. So it's going to eventually slew to that position, do some plate solving, then put it smack dab right in the center. So there we go. We're going to slew nearly 70 degrees. All
Hey,
right.
Richard. Hey, Richard.
Yeah.
Hey, did you happen to catch the
somebody messaged us from the UK.
Oh, we get visitors from the UK all the time. We actually probably have a member or two with us from there tonight.
Yep.
Yep. All right. So M31, of course, is the Andromeda galaxy. And so this was first noted as a small cloud in the Book of Fixed Stars by the Persian astronomer Abd al-Rahman al-Sufi in the year 964 CE. And the German astronomer Simon Marius was the first to describe M31 after observing it through a telescope in the year 1612. Charles Messier included it in his catalog in 1764. And many people knew it wasn't a comet, but again, he put it in there because the list kind of took on its own life, a life of its own. And so, as many people know, this is the nearest big galaxy to the Milky Way at only 2.5 million light years away. There are definitely galaxies that are closer to us, like, of course, the large and small Magellanic Clouds, but Andromeda, again, is the nearest big galaxy, and it is big, as we'll describe later. So I already mentioned its rough position with the all-sky camera, but here we are again with the Great Square in Pegasus. These three, of course, belong to Pegasus. This one belongs to Andromeda. The lines are not official in any way. Most astronomers don't even care about the constellations anymore, at least the professional astronomers. And to find this, you can start from Alpheratz, look for the brighter arc of stars, then look above each one for the fainter star. So there's a faint one there, kind of a faint one there, faint one there. And of course, you want to go from the first two there, and then the second pair, and then just kind of go up, and you'll see it right there. So it's pretty easy to clear in this image that I used from Starry Night Pro. So it's a very big target, which is ideal for the Takahashi. This thing really makes it look good. So it's located 1 degree west of New Andromeda, which is this star right there. Looks like it could be a binary, but I'm not sure if it is off the top of my head. So it's pretty easy to find for a beginner. And of course, the Andromeda is part of the local group of galaxies, which includes the Milky Way. The local group contains at present 55 known galaxies in kind of a irregularly shaped volume. That's about 1 megaparsec or 1 million parsecs in diameter. And of the bright galaxies, 14 are dwarf ellipticals, which is kind of considered the most common type of galaxy in the universe, because even the nearby ones are hard to see. 3 are spiral, or 4 if you count the Large Magellanic Cloud, which does have very spiral characteristics. Many do consider it a barred spiral galaxy. So if you want to get really technical, there are 4 spiral galaxies in the local group. And then there are 4 irregular galaxies, kind of like the Small Magellanic Cloud is considered an irregular galaxy. Now, many people might know that the Milky Way and the Andromeda galaxy are expected to merge or, collide in about 4 billion years. But if you've been paying attention to kind of recent astronomical news, this may not happen because of the aforementioned Large Magellanic Cloud. Some astronomers and some more recent research think that the Large Magellanic Cloud is going to tug at the Milky Way to make us miss a collision with the Andromeda galaxy. But it's just one study. It doesn't debunk many decades of thinking that we are going to collide. And it wouldn't make sense that 2 galaxies of that size, only 2.5 million light years apart, would eventually merge in the future. So maybe it's not going to be 4 billion years, 5 billion years. Maybe it's going to be 6, 7, maybe 8 billion years. But I would gather a guess it's going to happen eventually. Maybe they'll kind of miss each other at first and then loop back around and boop, and eventually merge into a supergiant elliptical galaxy that some call Milkomeda, you know, a combination of Milky Way and Andromeda. Like, okay, yeah, there we go. Oh, there we go. So for some reason, it stopped on me. All right, let's go see how we're doing. Back to ACP here. So we're doing really good on our exposure here. Got our guide star, looks nice and round, and we're almost done there. Let's go back to the all sky camera. Any Geminids? Ah, more clouds. So it looks like there's some rising clouds there, but we're looking really, really high here. There's Andromeda right there. Actually, this little smudge right there, that's it right there, right above the pointer. So it looks nice and clear up there. So this image should be pretty good. And we'll mostly work around this part, really kind of high up. We're going to work over here later. So hopefully we'll stay away from the clouds, at least for the most part, not counting the first target. But that was our last chance to look at the coat hanger, so I figure we might as well do it again since we haven't done it in a while. But no Geminids yet. I bet we'll capture one later, hopefully during the session, but oh well. So we're almost done there. We'll just let it ride its way out. I hope the YouTube stream is working. It is. I can't tell. Oh, there we go. Let me try to hit play. Oh, there we go. It's working. So hello to everyone watching us on YouTube. There's not too many over there, but there are some. And we're almost done. As usual, ACP will go like a few seconds past, even though Maxim doesn't actually show that. I don't know why ACP does, but it does. And hopefully you notice the sound is better than it was last month. Last month I tried using the microphone built into my speaker here, but I realized how terrible it was afterwards, so I got a more dedicated microphone. I used to wear the headset, but I didn't want to wear that anymore. All right, there's our thumbnail. Looks pretty good. Now I've got to wait for it to count stars. Oh, it's counted 44,212 stars. Somebody verify that with a hand count later, okay? I'd appreciate it. Now we just wait for it to plate solve. A lot of stars in there. Yay, 403 stars matched. All right, are we ready? So here's one of our regular targets. We do this every season because it's the Andromeda Galaxy. You kind of have to. All right, here we go.
Oh, that turned out all right.
Yeah.
Great.
Still probably a little on the hazy side. Looks like it's hazy all over. But that's not too bad.
I wouldn't complain. It looks like it has like a magical property to it.
Yeah.
Yeah, that's right. Hey, I have a question, Richard. So
Sure.
when it's counting the stars, what does that mean? Like, where is it count? Is it counting what's in that picture in
Yes.
addition to the Andromeda Galaxy? Oh, okay.
Oh, no, it doesn't count the one. It can't resolve the ones in the Andromeda Galaxy. That's just
Right.
not
I
big
know
enough.
that, but I mean, you've got the Andromeda Galaxy, that's the center, but then you have all of these other stars that are,
Yeah.
you know, white dots around this. So that's what it's counting. It's those stars in the picture. Okay.
Yep. Alrighty, a little bit about the Andromeda Galaxy here. Much of this you probably already know since it's so famous. Of course, this is the largest and most massive galaxy in the local group. Our galaxy is about 100,000 light years across. Some sources vary. Now, estimates for the Andromeda Galaxy are between 130,000 and 220,000. Because if you just say 130,000, you can go roughly from here to here, but you can see it extends outward. There's kind of a fainter bit that extends quite a bit further out than you see here. So that's where the 220,000 light years comes from. Our galaxy has about 400 billion stars. The Andromeda galaxy is estimated to have 1 trillion stars. It has a mass of 1.5 trillion solar masses, 1.5 trillion times that of the sun, compared to 850 billion solar masses for the Milky Way. It does contain a supermassive black hole, which of course you can't see here. It'd be black anyway, so you couldn't see it. It's 100 million solar masses, while our black hole is about, 4 billion solar masses. And there are at least 2 other galaxies in this image. There's one right here above the center. This is M32, which is a dwarf elliptical galaxy. In fact, they both are. So these are both satellite galaxies to the Andromeda galaxy. And M32 is actually located 24 arc minutes south of M31. So yeah, Andromeda actually looks upside down in the sky as we see it here. So it doesn't quite look like this when you see it in the sky. It's about 6,000 light years across. So just this little speck here is 6,000 light years. And it contains about 400 million stars. And it's one of the densest known galaxies. It very well could be a nucleus of a galaxy the Andromeda galaxy absorbed. And it may contain a supermassive black hole of about 2.5 million solar masses. Another indication it may have been its own galaxy at one point. Then down here is M110, another dwarf elliptical, and it contains about 10 billion stars, and it's about 16,000 light years across. And there is no evidence for a supermassive black hole, at least to the last time that I heard. So who knows? There could be one there. We just haven't detected it yet. So there we go, the Andromeda galaxy. And don't forget, you'll be able to download these images later. And the images you'll download are the full resolution, so you can zoom in even further than we can do here tonight.
That's awesome. Hey, Richard,
right.
what is the point of it counting stars after it's processed everything?
Mainly for processing later when you want to do like background balancing, that sort of thing.
Okay, because it was interesting that it's got 44,000, and then it resolved 403 of them. Well, I was just curious. Thanks.
I see. Our next target is IC 1848. Now this one, we're going to go crazy. We're going to do 10 minutes with the H alpha filter. So we haven't used the hydrogen alpha filter yet. So, of course, that tells many of you that we're going to do a nebula, because that's what that filter's for. Okay, so hit acquire image. And go back to this one.
Hey, folks.
So our next and final target with the Takahashi is IC, or Index Catalog 1848, known as the Soul Nebula. So IC 1848 is actually the designation used for the open cluster embedded within the nebula. The nebula is formally designated as Westerhout 5, or Sharpless 2-199, LBN or LINS 667, in LINS Catalog of Bright Nebulae, which was compiled in the 1960s by Beverly LINS. So, but most people just refer to this as IC 1848 because of the famous nebula. And this is its general location in the sky. Of course, the deep sky objects like the California Nebula and the Heart and the Soul, they're not that bright and obvious, but you can make them look that way in Starry Night, and it gives you a better indication of exactly where they are in the sky. And you can see it's pretty big. So again, that's why we're using the Takahashi. But it's actually located 4.5 degrees north of Eta Persei, right at the tip there. of Perseus, and 2.5 degrees southeast of the Heart Nebula, which in the chart version actually looks like a human heart. While the actual image looks like, the kind of Valentine version of a heart. And these are both located within the Perseus arm of the Milky Way galaxy, and they are connected by a bridge of gas. They are definitely related to one another. They are part of the same giant molecular cloud. And there are several small open clusters that are embedded in these nebulae. There's Colander 33 and 34, plus 632 and 634, which are not shown on the atlas, but you can see 33 and 34 are. And then of course IC 1848, which is the actual cluster here. So there is a small emission nebula, IC 1871, you can see it labeled here, found left of the top of the head of the Sol, because you'll see later it looks kind of like a person. And then there's a small emission nebula called 670 and 669 that are just below the lower back area, not quite seen here. So there's a lot in this region. We're looking at the constellation Cepheus, and this is a very, very dense region of the sky, all kinds of nebulosity, both bright and dark. So you might wonder, where do these nebulae come from? Oops. And one idea is called the density wave theory. So the density wave theory proposes that spiral arms and spiral galaxies are waves of compression that move around the galaxy, triggering star formation as they go. And because these waves move slowly, the orbiting gas clouds overtake the spiral arms from behind. And you'll notice in lots of colorful images of galaxies, the bright nebulae are, for the most part, along the leads of the spiral arms. On the opposite ends of the arms, you don't really notice much nebulosity at all. So that could be it. The density wave theory could help explain how emission nebulae form within galaxies. They basically collect gas and dust from previous generations of stars or unused gas from past nebulae, and they cause them to collect together along the fronts of spiral arms. So that's where nebulae like the Heart and Sol, how they likely formed. Okay, now we're doing a long exposure this time. So let's go back and check how we're doing. So we're only maybe a few minutes now into our exposure because, of course, the telescope has to slew, it has to plate solve, and then center the target, and then look for a guide star. That takes a minute or two. So we're still, we still have a ways to go. We can switch over to the all sky camera, and it's looking hazier than it was before. So I was afraid it was going to be like this, but oh well, that's not too bad. No Geminids yet, though. Darn it. I'm sure we'll capture one later. And go ahead and stop sharing there for a while. Of course, can't see most of you. Bunch of shy people in here, but can kind of scroll through the chat, see if doesn't look like anyone's posted any questions in the chat. So if you have any now, I'm certainly welcome to entertain them. We got time
Richard,
to yeah.
If you haven't seen any Geminis yet, don't feel so bad. I looked outside and seen any.
Yeah, I don't think you're going to.
Darn Michigan.
So, yep, we do have people all over joining us again. That's what's so fun about doing these, except most of you are quiet that are from far away. So, hey, speak up.
Richard, I do have a question about the Andromeda photo.
Sure.
Up above, I believe it was up above M32, kind of up at the top of the screen, and it almost looked like another galaxy. Almost looked like it had a central core to it.
Oh, up here?
Yeah.
Yeah,
what is that?
That's just a bright star, probably part of Andromeda that's shining through the clouds.
Okay, gotcha.
Trying to think of the, because you remember you have to rotate this thing to see how you see it in the actual sky.
Right, right.
You can see some, of course, some dust clouds and the spiral arms. There's a star cloud here. We've done this with the 20-inch before. We've imaged this one up close. That's kind of cool to look at with the 20-inch up close.
Do you remember which one that is?
It's NGC. I could probably go back and look on the Sky Atlas that I use, but
Oh, 4.
So yeah, that's a task for anyone. Grab your Sky Atlas or whatever and remind me what the NGC number of this is. It's in like the, I think 600s or so. I can't remember.
Pete
not
just
high
said
up.
Pete just said it was NGC 204.
Oh, okay. It's lower than I thought then. Okay. Because I don't have a Star Atlas handy with me. That's better. Well, let's do a weather check. Oh, now it's only 2 miles per hour. Still 30% humidity. The temperature doesn't look like it's changed at all. So it should have gotten a little cooler, but nope, nothing. So it looks pretty good. Let's see, we'll go back. Just watch ACP do its thing. It probably looks tinier than it used to because I used to run these from my laptop, but now I got a larger desktop computer with a big monitor, and it looks so tiny now. I can make it bigger though. I can bring up the sidebar there and kind of blow it up a bit. So if you can't read it, I can make it bigger. There we go. How's that? Is that easier to read?
Yes, thanks.
There we go. Oops. Oh, not that one. Oh, how did I do that? Let's see. Can I open that up? Oh, what's the top one? I can't remember what the top one's called. Hit the wrong button. Nope, not that one. Oh, shoot, I just lost it. Oh, system status display. There we go. Ah, that's better. Oh, the font's so huge in here, too. I wish I could make it small in the window, but bigger everywhere else. We'll scroll down there at the bottom. Let's see. I don't think we'll do too many H alpha shots tonight. Kind of looking ahead here. We might do one for that target. Maybe we'll do one more. Depends. Yeah, probably one more. We'll do another nebula with the 20-inch here soon. Any Geminids? Looks like it's thinned out a bit again. It's kind of getting kind of good then bad. You can see safe now. So you can remember the corner stars of Orion by saying, if you take some Betelgeuse, your belly will do some tricks. But if you take Rigel, you'll be safe. So we got Betelgeuse, Bellatrix, Rigel, and Safe, S-A-I-P-H. Then the belt stars are Alnitek, Alnilim, and Mintaka. Of course, hanging from the belt is the sword, which you really can't see right now. And of course, that's where the Orion Nebula is. We'll do that. If not next month, we'll do it in February for sure. That's another one of those targets you do every season because it's so famous and awesome. The Summer Triangle looks clearer than it did before. We could probably go back and redo the coat hanger. It's not the best night. And if you joined us last month, we did the Pleiades. Or did we do that? No, we didn't do that last month, did we?
No, we
forgot.
didn't.
We haven't done that one yet. We'll probably do that one next month. That's another one we do every season. I should try to do the Heidi's, but we can't. We can't even fit the whole thing in with the Takahashi, unless we put a focal reducer on sometime, which we don't have one. Not the we do have one for the 20-inch now that got donated, but we haven't gotten it out there yet. So we just imaged the Andromeda Galaxy, and let's see. I can't even. I think. Well, here's. I think this is the tip of Cepheus, but it's kind of hard to make Cepheus out. There's so many stars, it gets lost up there. And I just heard a chime, so I think our image is done. Oh, there it is. So far, it looks like a blob. That's a good start. Believe it or not. 11,636 stars. You would think it would be more because we're looking right into the disk of the galaxy, but we're looking through a lot of gas and dust, a lot of dust mainly. So not as many stars as you might think. Lots of nebulosity in this area. All right. It's done. All right, here we go. So here is IC 1848, the Sol Nebula. Ta-da! And yes, it looks like a penis. We'll process it a bit. We'll probably get it a little bit brighter in the final version, but there you go. That's only 10 minutes.
Looks like a turtle to me.
A turtle?
Yeah.
Yes. With big head, but a turtle.
Yeah, I can see it. The big-headed turtle.
So Richard, we couldn't get the Heart Nebula in there at the same time, could we?
No, I couldn't. I've never done them at the same time. So if anybody ever wants to do a mosaic of this, you'd have to or do these two together. You have to do a mosaic.
Because if you could put the Sol Nebula as we're looking at it in the upper right quadrant, you might be able to get the Heart Nebula.
Yeah, we might be able to. We couldn't have done it before with the old configuration, but now that we have a rotator, you might be able to rotate it just right to do that. But we currently don't even have that set up. We'll probably do that with the next version software that we have with Voyager. Because we're going to get a rotator for the 20-inch too. Since our new cameras will be 36 by 24. Yeah?
I'm sorry. So these in black and white, will they eventually be processed as in color too?
No, we only do the one image here.
You probably need the extra filters and all that to
right. Yes.
Green and blue.
Some people have done the false color. They kind of colorize it in Photoshop. It's not natural, but
right.
Of course, to make a more natural image, you have to do the RGB, but we don't take the time to do that during the sessions.
Absolutely. Okay.
Plus, we'd spend the whole time basically on one target.
Yeah. Looks great, though. Awesome.
So, yeah, as Kevin noted, you can see a little bit of the Heart Nebula here. You can kind of see the top of the heart shape here. So the Heart and Sol together span an area of about 300 light years. The Sol Nebula itself, at least I think the long axis, is about 100 light years across. And stars in this region are less than a few million years old. For comparison, of course, the sun is nearly 5 billion years old, like 4.57 or so billion years old. So these stars in this region, they're brand new because these are stellar nurseries. These are the places where stars are made. So it's shaped by stellar winds from stars embedded within the nebula, and it's home to W5, a radio source that spans an area roughly the size of 4 full moons. So the sky would look very different if you had eyes the size of wagon wheels. You might be able to see the radio sky. So the radio source has large cavities that are the result of nearby massive stars' winds, and radiation carving the nebula, pushing the gas together and causing it to ignite to form new stars. This is a process called self-sustaining star formation, where one massive star forms and its ultraviolet light and solar wind push gas around that triggers even more star formation. So those big stars might not live very long, but in the process, they help other stars form. That could be very well how the sun began to form. Some big star died and poof, it eventually gave birth to the sun. So finally, studies have shown that the stars are progressively and systematically younger the more distant they are from the center of these cavities. So there we go. These are the places where stars are born. The sun was very likely once embedded in a nebula like this. We don't know exactly how big or small it was, but that's where the sun came from, in a place just like this. All right, so that concludes our tour of the sky with the Takahashi. So before I do anything, I'll share the screen so you can see what I'm doing. We'll go back to, there it is. I thought it closed on me because I have to change the focal length before I forget, because as we've discovered in the past, I do forget. So we'll change it to 508 millimeters, which is about 20 inches, and 54 millimeters. That's what we need to plate solve with the 20-inch. Because if I keep it set up for the Takahashi, it won't work at all. So I don't know why I'm closing that stuff, because it's going to close automatically, but there we go. I'll hop back to ACP there. And then I'll switch or use our switching program to switch between the two telescopes. There we go. So eventually the Takahashi will close down, then we'll use the 20-inch here. So there we go. We're going to move on and use our Planewave CDK-20 telescope, our flagship telescope. So this is a 20-inch corrected dull Kirkham telescope. It's kind of a compound telescope, very much like a Schmidt-Cassegrain, but in this case, we have an ellipsoidal primary mirror as opposed to a more traditional kind of curved mirror on a Schmidt-Cassegrain. I can't find the word there. And then it has a spherical secondary mirror, very unlike a Schmidt-Cassegrain, which is flat. And then there's a lens group in the back, hence the term corrected dull Kirkham telescope. And these are supposed to give coma-free views with no stigmatism and a pretty flat field across the 52 millimeter plane. Although we've had issues with that in the past because we had to move the secondary mirror and we've had vignetting, but it's been improved upon a little bit since then. So the primary mirror is 20 inches. And as you noticed, it does have a focal length of 3,454 millimeters without the focal reducer, but we might add one here in the future. We're not 100% sure it'll work with the new system, but we'll see. It is pretty heavy, 140 pounds, and it is all carbon fiber construction. Here is the old imaging train. We have since removed the on-axis guider, and we now have the camera plugged in directly to the telescope here with no on-axis guider in the way. We were just never really terribly happy with the performance of the on-axis guider, so we kind of got rid of it. We'll probably eventually get an off-axis guider because our auto guider here is being used with a separate guide scope, and it hasn't really proved to be 100% great. So we'll probably use an off-axis guider. That'll be one of the things that we purchase with the money we'll get from the sale of the other 20-inch that got donated to us. And then we have a duplicate STX 16803. And on our new system, we will have different cameras on the two telescopes. They'll have very similar characteristics or similarities, but they'll be different cameras because we have had issues with using two of the same camera on the same system. It has caused problems before. We pretty much have them resolved now, but still, it does cause problems from time to time. So the workhorse is our software BISC Paramount ME2, which supports both the 20-inch and the Takahashi. It is a very good mount. Again, we've had some issues, but we think it's mostly with all the cabling we have running through the mount, but we hope to solve that pretty soon. But otherwise, we've been very happy with it. It is a very, very good mount. And so let's go ahead and switch over to ACP. It does sound like we are done. I heard it switch. And yep, sure enough, the switch has been successfully completed. I've already focused. So we're going to go down here and type in our next target, NGC 457. We'll hit get coordinates. I think we'll just stick with 5 minutes there. That's usually my go-to exposure. And we'll use the luminance filter because this is a cluster, so no H alpha necessary. Unless we do like a really, really deep image of this region, then yeah, we might want to do some H alpha. Then we'll go ahead and acquire the image. And let's give it a proper introduction here. All right, so NGC 457 is the owl cluster. One of my personal favorites to look at through a telescope, at least in terms of open clusters. So this is also designated as Caldwell 13, Colander 12, and Millet 7, amongst many other designations. The owl cluster name is from David Eicher in the October 1980 issue of Astronomy magazine. It's classically known as the Phi Cassiopeiae cluster. Other names include the Kachina doll, the dragonfly, stickman, number 5 from the movie Short Circuit. And again, if you know the movie Short Circuit, you are officially old. And the ET cluster, which came about roughly around 1982 when ET came out in theaters. Tom Lorenzen and Tom Schuyler referred to NGC 457 as the ET cluster in their 1987 book, 1000 Plus, the Amateur Astronomer's Field Guide to Deep Sky Observing. Which, let me go ahead and I'll stop sharing here. I always wanted to get a copy of that, so here it is. I don't know if I can get it to stay in focus there. It thinks it's the background. Well, anyway, that's it. There you go. Oh, that's better. Yeah, let's cover up my face. But now I can't see what I'm doing. So yeah, this is a neat book, by the way. It was kind of hard to find, but there it is. So I wanted to share that. One of these days I'll bring it to a meeting if I can remember. And this was discovered by William Herschel on October 18th, 1787 with his 6.2-inch reflector. He described it as a brilliant cluster of bright and very faint stars, considerably rich. Here is its general location in Cassiopeia. Here is the Sol Nebula, where we just were. And of course, there's the Heart Nebula. I think we did this last year. And we've done the California Nebula before, and there's the Pleiades over there for reference. So it's right below, the W of Cassiopeia, or it's above the M, depending on what perspective you have. And it's located 2 degrees south-southwest of Delta Cassiopeiae, often overlooked due to its proximity to M103, because those Messier clusters tend to get all the glory, but I prefer NGC 457 over M103 any day, personally, for visual observing. All righty, so let's see how we're doing. Hopefully we're doing good. Oops, I forgot what I'm doing. Oh yeah, I gotta switch back to ACP. Now I can't do it again. Oops. Okay. Somehow switch back to the other TV. That's weird how I did that. Okay, so let me go back to ACP. There we go. All right, so we had a bit of slewing to do, obviously. And now we're roughly 113 seconds into our 300-second exposure. Very smooth guiding. Check for Geminids. Oh, darn it. So we're roughly looking right around what, here? Was it? Or is it above or below the? It's above the M. So it's right around here. Pretty clear up there, so it should be a pretty good image. The clouds are staying away. That's good. Hopefully we'll get by our last two targets without any issue with clouds, but can't control the weather. And if you do scroll down here, I noticed this page, our cloud sensor graph is not updating, so we need to look into that. It is, there is a new version on the computer, but it's not updating on the website. So there's a problem with the program we use to upload the new images. You can see Monday looks pretty good. So Tim Kurtz is probably making a reservation for Monday night right now. Maybe even Tuesday, because they look pretty good. Then you can even see the current moon phase. What is today? 13th. So there we are. So the moon won't bug us for the session, but it's going to pop up later and ruin the whole sky up here because it's bright and obnoxious. We hate it. That's just my personal opinion anyway. All right, we're trucking along there. And let's see, while we're waiting, see if I can pop the chat up here. Has anyone heard about the asteroid that is passing on the 19th? I don't think I have. So if anyone else has heard about that, I have not. If I have, I don't remember it. Oh, Pete was wrong. It's not NGC 204, it's 206. Oh, Pete, you should be ashamed of yourself.
I'll hand in my astronomer card now.
That's right. Yep, Johnny 5 is alive. Thank you, Tim. Again, if you don't know that reference, you are young and therefore terrible. Just kidding. Almost done. Uh-oh, what happened to the guiding? That's not good. Let's check the computer there. No, I don't want to upgrade the software right now. We'll do it later. It keeps bugging me about that. Okay. Oh, I have to fix the screen here because it switched telescopes. We'll move that over there. I hate it when things move on me. Here we go. Well, if our guide star moved a bit, we missed it. Oh dear. Now it's gonna. Did I mention we need a new computer too? Oh, because it was almost done. Okay. Well, I'll let it work. That I don't want to move it around while it's working. Oh, there it is. Ah, spoiler! Spoiler! Don't look. Turn away. All right, 16,871 images. Obviously not as much nebulosity in the way. And we're looking right at a cluster. That helps too. A big cluster anyway. Oh, you can even see the focuser position on the 20-inch. I just mentioned that. There's nothing really special about that number. Only 209 stars solved. That's crazy, considering how many stars are in there. All right, here we go. NGC 457, the Owl Cluster. Our first target with the 20-inch tonight. Ooh, very sparkly. Oh, and we got a satellite too. Oh, boo. Still kind of hazy.
Looks like something I've seen before. I like it. It looks great.
Yeah. Can you see the owl? These are his eyes, of course. Be kind of a wing there and kind of a wing here.
Where's the satellite?
It's going here. Maybe you can't quite see it on some screens, but it's right here. The streak there.
Oh, okay. All right. It's like kind of streaky. Is it streaky?
Yeah.
Yeah. Okay, yeah, I don't see it on my screen, but I have a little laptop, so maybe that's
Really beautiful.
You will see it when you get the full resolution version.
okay. Probably.
Oh yeah.
Of course, the satellite will always be clear. Everything else may have a little haze to it, but that one's clear, of course.
Yeah. Unless it's a really bright satellite, then maybe. Or it's a bunch of Starlink satellites. Boo.
And concerning the December 19, I heard that there's a comet hopefully visible.
Is that when Comet Atlas is supposed to make its closest approach to Earth?
Yes.
I know that's coming up. Eventually, we'll try to do that during an online session, but it's not up at a good time for us. Alrighty. So this cluster has an estimated age of 21 million years, which is pretty young, with a true diameter of about 46 light years. Pretty respectable. It features a rich field of at least 200 stars between magnitudes 9 and 13. About 60 stars have been identified as true cluster members. The rest are just ones along the Milky Way. The two bright stars are Phi 1 Cassiopeia, magnitude 5, multiple star, with a rare F01A primary, a star hotter and larger, more massive than the sun. And there's also HD 7902 C or Phi 2, which is magnitude 7, and a B61B type star, which is a supergiant star, much hotter even than the type F star, which are the eyes. It's unclear if Phi Cassiopeia is a cluster member. If it is, then it would be one of the most luminous stars known, about 215,000 times the luminosity of the sun. That's a lot. 26 solar masses, 250 times the sun's radius, and about 6 million years old. That big guy right there. So that could be a monster just waiting to blow. The two supergiants share a similar space motion to other stars in NGC 457. Their Gaia data release, Gaia is a probe that measures the position and distances of stars. So their Gaia data release to parallaxes are comparable to other cluster stars and consistent with NGC 457's accepted distance. And component C has a 70% likelihood of being a cluster member. So we're studying and learning new things about this cluster all the time. Really fun to observe through a telescope too, because it really, really pops out at you with the two bright stars and kind of the elongated body. All right, there we go. Our next target. I gotta be honest, we've done this one before, but I can't quite remember what it looks like. So we're gonna give it a shot. But we'll kind of refresh our memory here. So this is a nebula. So let's go ahead and go crazy again. I think we're doing pretty good on time. So we'll do 10 minutes with the H alpha filter. And go ahead and start that off there. There we go. So NGC 7380 is the Wizard Nebula. So the Wizard
Nebula.
The Wizard Nebula is an emission nebula that surrounds the open star cluster NGC 7380. Just like with the Sol Nebula, the designation we use here is actually for the cluster, not the nebula. So the nebula itself is cataloged as Sharpless 2-142, in the 1959 Sharpless catalog. This was discovered by Carolyn Herschel on August 7th, 1787. We talked about Carolyn Herschel a little bit last month with NGC 253. And so it was discovered on the occasion of being free from recording duties when her brother William was absent. So she was able to observe, because remember at first she just recorded observations of him, but eventually she started to make a lot of observations on her own. And this was observed by her brother William Herschel on November 1st, 1780. He described it as a cluster of coarse, scattered stars, 8 arc minutes in diameter. And here's a nice sketch of it that may or may not resemble the final image. We'll find out. And here's its general position in Cepheus. So we were there with the Sol Nebula. And then we kind of went over here for the Owl Nebula. Now we're over here for the Wizard Nebula. I mean, we're over here for the coat hanger. So we're kind of working our way around the Milky Way there tonight. So it's located about 2.5 degrees east of Delta Cephei. Right there. There we go, Delta Cephei. And it is extremely difficult to observe visually, requiring very dark skies and an O3 filter. I don't recall ever actually observing this before. But we have imaged it before, at least once before, and we're going to do it tonight, because I certainly can't remember what it looks like off the top of my head. And it sounds like it's working on it in the background. So let's go ahead and check in on our progress here. Oh, we're still slewing. Hasn't even started doing the guiding yet, so it must have been on the other side of the meridian, so the telescope had to slew all across the sky. Oh, well. That's okay. Check our all-sky camera. The clouds are still kind of clinging to the horizon. Maybe some thin stuff we can't see overhead. Could probably bring up a satellite view later. In fact, we can do it now. We can kind of go down here. Oops. Oops, shoot. I shouldn't have. I moved it. We can go from here to, let's see, I think there's an infrared view here. Let's try satellite. Yeah. Yeah, so we're kind of like right around here. So we haven't got the bad stuff yet around Tucson there, but it's coming to us. We'll see. Not a bad night for an online viewing session, though. We're going good there. So we got quite a while to go. So I'm desperate for material, folks. Anybody else have any questions or comments or any introductions anybody wants to make?
It's snowing pretty good out there right now.
Is it? I don't have a view out the window. Probably looks terrible.
I just ran to go pull the car and like, oop, I got to brush it all off now.
Great.
No stars tonight, except yours.
Hi, I was just trying to put a picture up, but I can't figure out how to put a picture up there. So,
oh, we don't let people share too much during the online viewing sessions. Afterward, you can share some stuff.
Yeah, I thought I could put it up as a background. It was a nice Northern Lights picture that I took.
Oh, okay. Yeah, you can share that after we wrap things up here.
Okay. From my backyard in Kansas. I thought I'd never see the Northern Lights like that in Kansas.
Oh, wow.
Yeah.
Great. I like the astronomy picture of the day from yesterday. It was from Finland, and there's a nice firefox in the foreground. Sounds like he was running around the photographer as he was taking aurora pictures, so he was hard to get a picture of. He's a cute little booger. So if you don't check out astronomy picture of the day, I encourage you to do so. It's a cool picture from yesterday. I forget what the one for today is. I'll have to go check again. It's one of those websites you should check out every day. See if I can close that. There we go. Mhm. Oh, yep. Yeah. So Muhammad verified that. Yeah. 3i Atlas. And it's 3i Atlas, Muhammad, not 31 Atlas. A lot of people make that mistake. Yeah. It'll be closest to us on the 19th, but still, it doesn't get as close to us as it did to Mars a month or two ago. Really got close to Mars.
Yeah, you keep saying, Richard, that it's not a bad night out there. I'd take that night over here every night.
Oh, sure. It'd be a good night to watch the Gemini, especially at 61 degrees.
Yep.
Just need like a sweatshirt or something.
All day long.
Yeah.
I'm looking forward to visiting.
Yeah.
I'll be down there on Friday.
Uh-oh. Did we lose our guide star? Oh, let's go back to ACP and check our view there. Oh dear, looks like we did. Uh-oh. Uh-oh, something happened.
As an aside, I've been imaging this same object, and
Yeah.
I've been having problems with it at altitude on the east side of the meridian at that altitude.
Yeah. Uh-oh. Yeah, gosh, where is this? I can't remember where we were. It's in Cepheus. Yeah, so we're pretty close to the meridian. And this is the issue we've been having with our mount because of all the cabling we think running through the mount. And we're going to install a Pegasus power box so we don't have to plug or run everything through the mount. But yeah, it looks like we've lost our target. So why don't I go ahead and stop that? Darn it.
Those darn wizards and their invisibility cloaks.
I know. They don't want to be seen. All right. Maybe we'll come back and try to do that one. Let me see. Where's our next target? Yeah, that's a little further away from the zenith. So let's jump. We'll try to come back to this one. Let's go ahead and do the next target. We'll do our final target, NGC 7331. We're going to do 5 minutes for that one.
Hey, Richard, did it do any acquiring at all?
It did. It was taking the image. It just lost the guide star.
Okay. It'll give you what it's got then, and you can make a photo out of that then.
Oh no, it'll be so. It probably chased the star.
Gotcha. Yeah, probably trailed. Yeah.
So it's probably going to be beyond recognition.
Yep.
If we have to, maybe we'll try an unguided one, but even 10 minutes is kind of pushing it. And we probably want to do 10 for that for sure. Okay. So yeah, that's a tricky one. All right, so let's go ahead and talk about this target. And if we can't get it, we can't get it too. But we can come up with a third spontaneous target, maybe. Doesn't have to be planned, but.
Well, you're right there at 7331. You could do, well, no, that'd take the 5-inch to do Stefan's quintet.
Yeah, it's very tiny too. I would like to do that one sometime, but it's small.
Well, you could do it with a 20-inch, couldn't you?
It's still pretty. I've done it before. It's small.
Oh, really? Huh.
Very small, yeah. We can try it though. But it won't quite be in the field of view here. Okay,
that is
so
really beautiful.
So our next target is NGC 7331, the Deer Lick Galaxy. More on that in a minute. So reportedly, Tom Lorenzen, author of 1000 Plus, the Amateur Astronomer's Field Guide to Deep Sky Observing, which I shared with you later, gave the group its name in honor of the Deer Lick Gap in the mountains of North Carolina. So I've always wondered where the name Deer Lick Galaxy came from after the Deer Lick group. And apparently it's the Deer Lick Gap in the mountains of North Carolina is where it gets its name from. How it got those two connected, I have no idea. Maybe that's where he viewed it one night and decided to name it that. And there are other, the other four members of the Deer Lick group are NGC 7335, 7336, which are both unbarred spirals or regular spiral galaxies. And there's NGC 7337, a barred spiral galaxy, like the Milky Way galaxy, by the way. And NGC 7340, which is an elliptical galaxy. And these are affectionately referred to as the fleas. This galaxy was discovered by William Herschel on September 5th, 1874. So here's its general position in the sky, kind of above the leg of Pegasus, the winged horse. It's in a pretty off-beaten path of the Milky Way, at least. We're looking way out in deep space here. And it's located about 4.5 degrees northwest of Eta Pegasi, or Matar, I guess that's how you say that, beneath the flying horse's front legs, as I mentioned. And Kevin mentioned Stephan's Quintet. And you've seen Stephan's Quintet before if you've ever seen the movie It's a Wonderful Life. Because at the beginning of the movie, where you see, like, the angels talking in space, they show probably like a polymer image, I'm guessing. I'm not sure where the image came from. And that image is Stephan's Quintet. That's like a polymer image, probably, of Stephan's Quintet. So next time you watch It's a Wonderful Life during the holiday season, that's it. So since we're looking at NGC 7331, which is a spiral galaxy, this seems like a good chance to introduce you to the Hubble Galaxy Classification Scheme, the basic way we still classify galaxies today. Of course, it's a little more complex now than what you see here, but it's still pretty much this general classification scheme. And this is also known as Hubble's tuning fork. And when Edwin Hubble first developed this, he thought it was a evolutionary chart. Like, maybe ellipticals evolved into spirals and so on. But it's actually turns out to be the reverse of that, as we saw earlier. It's just like spiral galaxies can merge together, kind of like the opposite direction here, and become elliptical galaxies. But they can't become like an elliptical galaxy all by themselves. They have to merge with another galaxy. So yeah, here we do have elliptical galaxies. And so the number after the letter, E, of course, is for elliptical, this comes from a little equation. You just measure the diameter and the kind of the height of the galaxy, plug that into this little equation. So if A and B are equal, that, of course, is 0. So you get a very round elliptical galaxy. In fact, it's not really elliptical at all. It's very circular. So the larger the number, the more elliptical you are. Eventually you get to like E5s and down to E7, where you look like a football or, Stewie's head or something like that. Then we have the SO galaxies, which are lenticular galaxies. They're just like spiral galaxies. They have a central bulge. They have a disk, but no spiral arms. And they tend not to have much in the way of gas and dust either, much like elliptical galaxies, because elliptical galaxies really contain no gas and dust, and thus no star formation. But lenticular galaxies do have a little bit of star formation, but typically not very much. Then we have spiral galaxies. We have our regular spiral galaxies with no obvious barring. So if you're an SA galaxy, that means your arms are tightly wound. If you're an SC galaxy, then your arms are very open and wide. And then, of course, down here, we have the barred spiral galaxies. So again, if you're an SBA, that means you're a barred galaxy. You can see have a bit of a bar here. It looks like it's kind of going this way, actually. And there's a bar this way, too. So you have this tight bar with tightly wound spiral arms. And again, the higher up the alphabet you go, the looser the arms get. So the Milky Way is kind of around this area here, I believe, an SBC, but I always thought the arms were probably a little tighter. So I always thought it should be an SBB. And I believe NGC 7331 is roughly an SB galaxy. It's not an obvious spiral galaxy. And it sounds like we just finished our image there. Hopefully it went well, because we didn't really check in on it very much. So let me advance the slide there and we'll check our progress here. Oh, there it is. Okay. And again, we're looking way off the Milky Way. So look, only 6,481 stars imaged. Doesn't seem like there's that many in the image. And we just wait for it to do the final work there. Tick tock, tick tock. We're doing good though. We got plenty of time. And you can see why we want to get a new computer. It's slow. Takes a lot of time to count those stars. Only 172, and it took that long. Okay, here we go. So here's NGC 7331, the Deer Lick Galaxy.
Ooh.
Pretty. There's the fleas. You can see a few fleas around there. Another galaxy up there. That could be a flea, I'm not sure. There's at least 1, 2, 3, 4, 5 other galaxies in there at least. Maybe another one there. There's probably one on the edge right there, it looks like. Another galaxy down there. Kind of maybe a faint one up there. That one looks pretty clear. No obvious hazing on this one. So that looks really good. So if you really look at the image, you might see that the core of the galaxy appears to be slightly off center. That could be an effect of dark nebulosity. It belongs to the Pegasus spur of galaxies, which is a small gathering of 35 systems that includes Stephan's Quintet, made famous from It's a Wonderful Life. And it is classified as an SBC galaxy. So it is kind of a slight barred spiral with tightly wound arms. The disk is tilted about 22 degrees from edge on. It's obviously not edge on, so it's tilted about 22 degrees from that. It has a diameter of about 120,000 light years, so maybe a bit bigger than the Milky Way. And it has a total mass of about 300 billion suns. So maybe bigger than the Milky Way, but maybe not quite as massive as the Milky Way. And Stephan's Quintet is about a half degree south-southwest of this object. And it's only takes up about 3.5 arc minutes of the sky. And it's named for its discoverer, Edouard Stephan, in 1877 at the Marseille Observatory in France. So this is our most distant target of the night. Much more distant than the Andromeda Galaxy. All right, well, let's try our last target, our previous target one more time. Let's see if we can do it. If not, we'll just go ahead and throw in the towel on that one. We can do a bonus object with the time we have left. We'll give it a shot. Hopefully it's gotten past the meridian enough to where it'll guide a little better. Yep, we're hoping to get rid of this issue with some of the upgrades we're doing. So see how far we have to slew. We'll wait for it to pop up here. Just 24 degrees, that's not too bad. Check the all sky camera. Looks really clear on the western horizon compared to when we started. Still a little milky on the north and the south. Really bad in the east there. Orion's really gotten higher since we started. And I believe there's Jupiter with the with Gemini, Castor and Pollux. So winter's coming. If you didn't notice, if you're in West Michigan, if you didn't notice, winter's coming. There's the constellations to prove it. And let's go ahead and watch this from the home computer there. That'll tell us for sure. Yeah, maybe after we finish up here, I'll update Focus Max. And there's our field for guide stars. Okay, so we have our guide star. It's guiding, but starts out very smooth. We'll see what happens. Yep, winter's definitely here. All right, so I hate to walk away from this and not watch it, but while we're waiting, so let me go up to the PowerPoint here and we'll mention a few things. So, of course, if you live in Southwest Michigan, you can use the remote telescope. This goes to current members or potential future members, but you must live in one of the counties in red here. You might wonder, well, why don't you open up to people outside the county? Is because we're all volunteers. We can't quite handle that kind of load that we might get, that we'd probably get. And right now, as you can notice, it's not commercially ready yet, even though we've been using it for a while. It's not quite reliable enough to use for a commercial thing, even though it's roughly 90% reliable, but there's still glitches here and there that we have, and we just can't handle, I think, the load we would get if we open it up to people around the country or around the world. So we just keep it to folks in Southwest Michigan here. So you can join the Kalamazoo Astronomical Society and use the remote telescope. You just got to pay the regular membership fee plus just $50 a year, which compared to a commercial remote telescope is incredibly cheap. I mean, incredibly cheap. And if you haven't done so, you can register for the next online viewing session. I forgot to make copies of the links again. So Kevin or Pete, if you can get the registration link for the next session and post that in the chat, I'd appreciate it. So our next session will be January 10th, which is the day after our general meeting. And we do have a very special guest speaker I'll mention here in just a minute. And if we do have foul weather on the 10th, we will try again on the 17th, which is the first day of the Introduction to Amateur Astronomy lecture series that I'll mention here soon. And notice we're starting at 9 o'clock because after December 20th or 21st this time, days will start getting longer again. So we'll have to start a bit later. So if you are a current member, you don't need to worry about this part. But if you're not already on the online viewing session email list, you can do so here tonight. You will get reminders about the sessions. You will get registration and YouTube links. You will get a link to download the session images, and you'll get notification of a postponement or, heaven forbid, a cancellation. I'm pretty sure the QR code works. That should take you right to the form to sign up directly for the email list. Or if you want me to add you, you can use our contact form or just email us at this address. And I would be happy to add you to the online viewing session email list. We have roughly about 400 people on there right now. As I mentioned earlier, next year is our 90th anniversary. So it's a big year for the Kalamazoo Astronomical Society as we celebrate our 90th anniversary. We are the oldest club in the state of Michigan, and we are going to kick the year off with a bang with one of our biggest speakers ever. So Professor Sarah Seeger from the Massachusetts Institute of Technology, MIT, will join us via Zoom and speak on Venus as a potentially habitable planet, because she's one of the leads on a new mission to study Venus's clouds and look for evidence of potential life. So we're really excited for her to join us via Zoom during our first event of our 90th anniversary. So you can join us in person at the Kalamazoo Area Math and Science Center, or you can join us via Zoom. And if the weather's really bad, then everyone can join us via Zoom. We'll see how it works out. And as I mentioned, our Introduction to Amateur Astronomy lecture series returns starting January 17th. Over 300 people have already registered. So you can get on the Introduction to Amateur Astronomy webpage and register right now. And again, if you attend all 5 sessions, you will earn a certificate of completion and you will be a full-fledged amateur astronomer. But not until then. You have to attend all 5 to become a real full-blown amateur astronomer. Okay, not really, but it's for fun. And here is the link to download tonight's images. Now, again, if someone could post that into the chat, I'd appreciate it. Next month, I'll try to do better. But this is the link to download tonight images. Of course, right now, it doesn't work because we just took the images. And remember, we're working on one right now. So they're not there yet. I got to download them. I got to process them. And then I got to upload them. Now, last month, I had them on later that night. I'm going to try to do something similar tonight, but give me until at least Tuesday in case things get crazy. So don't email me until at least Wednesday and saying, hey, Richard, where are the images? Because if I don't have them by Wednesday, then you can go ahead and bug me. But until then, you know, I'll do the best I can. All righty. So let's see how we're doing. Oh, should have went right to ACP there. Oh, we're doing much better. Okay, that's good. I should have watched it, but hey, we had stuff to do. So the guiding looks much better this time. Just a few minutes, and that's all it took. Because yeah, we still have issues guiding near the zenith, and that is pretty high. So we're getting there.
Doing better on the west side than the east. I haven't put my finger on it yet.
Yeah. We still have a while to go. Let's check the all-sky camera. I was hoping to get at least one Geminid. I mean, come on. Nope, nothing yet. I forget exactly where the radiant of the Geminids is. It's somewhere around the top, I think. I think it's above the heads, or like north of the Castor and Pollux here. Somewhere around here. So we could see one like streak across the image here. That'd be good. Could be going this
early
way.
in the night. It would be definitely like a grazer.
Yeah.
Long. Hey, Richard, I was going to put a link to the Zoom meeting for January, but you don't have the Zoom links up.
Oh, they should be on the website. Let me see if I can get one.
No, I looked.
I put it up there.
No, for the meeting?
Here. Yeah, here it is.
The meeting. Never mind. No,
Hang on, I got it. Yeah. Okay, let me type that in there.
Oh.
January general. I can't type. General meeting. Here we go. Register now or forever hold your peace. Definitely join us for the January meeting. That's going to be awesome. What's the membership fee? Oh, I can tell you that right now. Let's see. Let's go to the online form. And we can scroll down there. You can see a regular
cheap.
one-year membership is $21. Yeah, compared to some clubs, especially the one just north of us, we're cheap. $21. It's a little more expensive online. It's cheaper if you want to download the. It's like $1 cheaper if you use the printable membership form and mail it in. But of course, you have to wait for us to get it and respond. And who has that kind of patience these days? Not us.
And the post office will lose the mail.
Yeah, the post office might lose the mail. But here are the rates for regular family, senior family, students, seniors. And if you do live out of state, we do have a supporting membership of just $10, and you can join for up to 5 years. So for $50, you can be a member for 5 years. And of course, don't check the remote telescope fee if you don't live in these counties, because I will instantly refund your money. Well, maybe not quite instantly, but I'll do it pretty quick. All right, how we doing? Oh, we're almost done. Okay, there we go.
Oh, we got an extra 1 second. Special.
I know. Only one. Sometimes it goes as much as 5. Why? I don't know. The remote telescope fee, if you didn't see it, it's just $50 a year. Cheap. Oh, there it is. Oh, it's bigger than I remember. Oh, I thought that was a number of stars. No, that's the focuser position. I was like, well, that's a lot.
Is this with the remote, with the big scope or the TAC?
Yep. No, this is with the 20-inch. We're still on the 20-inch. It's counting. Counting. 1 Mississippi. 2 Mississippi. Oh, there we go. Oh, only 4,477 stars found. All right, here we go. Finally, a bit of a delay, but here's NGC 7380, the Wizard Nebula. Ta-da! It's pretty faint, obviously, but it'll look better when I process it a bit. But
I like
that's
how
why.
I like how it looks layered.
Yeah,
that's pretty neat.
That's why we take like hundreds of these and stack them together to really bring it out. But this is what a single image of this looks like.
In colors, is there a lot? It's reds and any greens and that sort of thing.
No, mostly red.
Okay.
Reds and blacks. Lots of blacks because of the dark nebulosity.
Okay, that's really neat.
Is that with a hydrogen alpha filter?
It is. Yep.
Okay. Well, I was just wondering if it was put back in because 7331 was without.
I did remember. See, we'll scroll down here. There it is. See, I didn't forget. That looks pretty good compared to what it looked like. What it looked like earlier if I didn't stop it. All right.
Send you one of those subs if you want to know what it looks like when it isn't.
Yeah, you can share that afterward here. So that basically concludes the December online viewing session of the Kalamazoo Astronomical Society. I want to thank everyone that joined us tonight. I hope you have a great holiday. I hope you survive the terrible winter months we have here, because maybe it could be clearer where you are, but in Michigan, we get the great permanent cloud and it just never goes away. So we don't get to see the sky too much this time of year, but that's why we have the remote telescope, so we can do this when we can't go out and observe the sky or image the sky. We share the sky as seen above the dark skies of Arizona Sky Village. So thanks again for joining us, and we hope to see you next month for our 90th anniversary.